Okay, this is my first attempt at screencastify, so bear with me here. And I'm also writing with the mouse, so this could be interesting. This is the how to find trig values without a unit circle video. And here's a sufficiently complicated problem that we may encounter later in the fall that requires us to input some trig values. So we're just going to wave our hands for the moment and arrive at where we need to be. So here, let me go back to the top here. A problem that we often encounter in calculus is find the equation of a tangent line through a specific point. So here's a trig function, cotangent x plus 9 cosine x, and we want the equation of the tangent line through the point x equals 7 pi over 6. We do a bunch of calculus stuff that you'll learn all about in September and October. And we get this weird notation, which again you'll learn about in the fall. And we have negative cosecant squared x minus 9 sine x. And we need to evaluate that at 7 pi over 6. And if you're like most calculus students, at least early on, you've completely forgotten what the secant of 7 pi over 6 is and the sine of 7 pi over 6. So I'm going to show you how we can deal with this without a calculator, because oftentimes you won't have one, and how to deal with it without a unit circle. So there are four things we need to keep in mind. 180 degrees is equal to pi radians. In calculus, radians are the main unit in trig land. We're done with degrees, except for very specific applications. 99.999% of the time, you're in radians. So start living in radian world. We're done with degrees. If you remember that pi radians is a semicircle, you'll be just fine. We need to know the positive and negative rules for each quadrant. What I mean by that is we need to know what's positive in the first quadrant, what's negative in the first quadrant. Well, the good news is all trig functions are positive over here. In the second quadrant, sine and its reciprocal are positive. Hopefully you remember the reciprocal of sine. In the third quadrant, tangent is the only positive one, and its reciprocal, of course. And then in the fourth quadrant, cosine is the and its reciprocal are the only ones that are positive. All or everything, sine, tangent, cosine. And again, with these three, their reciprocals follow the same rule. So sine and its reciprocal are positive. Everything else is negative. Tangent and its reciprocal is positive. Everything else is negative. Cosine, its reciprocal are positive. Everything else is negative. All students taste chocolate. No, that's a good way to remember it. We also need to know the rules on the axes. For example, we have these special points. Hopefully you remember what that coordinate is. 0, pi over 2, 3 pi over 2, 0 pi over 2, pi, 3 pi over 2. And this coordinate is 1. 1, negative 1, negative 1. We need to know what those values are. Those are fairly straightforward. And last but not least, and this is the key to doing the whole thing, you need to know your special right triangles. 30, 60, 90, and 45, 45, 90. Come on, mouse. A little bit of lag all of a sudden. There we go. If you remember those two triangles, you will unlock every value on your unit circle. If you don't remember those values, if you do not remember these triangles, then you got to memorize the whole unit circle. There's no way around it. So let's look at our special right triangles. 30, 60, 90. The key to this triangle is to remember that it is half of an equilateral. Now I've drawn it kind of sideways. Normally we draw the equilateral triangle this way and we cut it like so. I'm drawing it like this. I'm cutting it this way so that I get the 30 here. And you'll see why in a moment. Here's my origin. So this is in the first quadrant. I make the short leg 1, I make the hypotenuse 2. The short leg is 1/2 of the hypotenuse. Because again, if I put up, actually I have one to scale here. Here's an equilateral triangle. If I do this, we remember our geometry, drawing this altitude cuts that 60-degree angle exactly in half. And this one's a little different. I've got it, okay. I've got it turned ever so slightly. Mine's more like this. But it still fits. Here's our 30. Here's our, like so. Cutting this angle in half cuts this side in half. So since this short leg, this side is half of the whole thing, and since all three sides are equal, this is half of this. This, half of this. So if I call this 1 unit, that's 2 units. By the Pythagorean theorem, this is the square root of 3. Now we have everything we need, except for radians. So that was point number 1 on our little list. 180 degrees equals pi radians. From this, I can get anything I want. Anything I want. Our original problem stated that we have 7 pi over 6. So 7 pi over 6. I multiplied this by 7 and I divide it by 6. Well, that means I take 180 times 7 over 6. These make 30. 180 over 6 is 30. Times 7 is 210. And 210, there's 180. That's 30 degrees in the third quadrant. So I have a third quadrant triangle with 30 degrees at the origin. So I can now adjust my triangle. Origin, 30. Here's my -1 unit. Now remember, it's negative. We're in the third quadrant. Hypotenuse is always positive. For some reason I can't do a 2. There we go. More leg. And this, again, is negative. Oh boy, that is awful. Square root of 3. There's the triangle we'll use for our specific problem. And notice how I did that. I took this value of pi, I adjusted it by multiplying by 7 over 6. It means I multiply this side, 7 over 6. Now I know which angle I have. Although, if you learn how to count by pi, it's actually quite easy. Here's another conversion that you might want to memorize. Pi over 6 is 30 degrees. Every 30 degrees is 1/6 pi. Whoa, what am I doing? Pi over 6 is 30 degrees. So, if I have a 60 degree angle, that's 2 pi over 6, which is really pi over 3. If I have any angle over 6, it's going to be something that's 30 degrees above or below the x-axis. If I have 60 degrees, that's a pi over 3. And if we take a look at our unit circle, we can see those patterns merge very quickly. Here's a pi over 6. It's 30 degrees. 2 pi over 6, 60 degrees. Here's 3 pi over 6. It's 1/2. Now we're on an axis. 4 pi over 6. That reduces to 2/3. That's 60 degrees above the x-axis on the other side. Just like this pi over 3 is 60 degrees above, this pi over 3 is 60 degrees above. Same thing with 5 pi over 6. It's 30 degrees, or pi over 6 radians, above the x-axis, just in a different quadrant. In fact, notice I can tell which quadrant I'm in simply by looking at the fraction. These are all single coefficients of pi, first quadrant. All of these fractions, the numerator is 1 less than the denominator, second quadrant. The numerator is 1 more than the third quadrant. Sorry, 1 more than the denominator, third quadrant. Here, the numerator and denominator are different by more than 1, fourth quadrant. Anytime we have a denominator of 6, that's the first one we run into above or below the x-axis. That's going to be a 30-degree reference angle. 30 degrees up, down, up, down. If it's a pi over 3, we're going to be 60 above or below. And then we look at the fractional part to determine what quadrant we're in. If it's over 4, that's going to be the 45, 45, 90 triangle. So a quick refresher of that. The two legs are the same. I call them 1 and 1. I can call them anything I want. 1 and 1 is the standard, and then that is the square root of 2. So now I can find anything I want with that. And again, 45 degrees, that's pi over 4. And any pi over 4 is going to be that 45-degree angle. 3 pi over 4, the numerator is 1 less, second quadrant. Numerator is 1 more, third quadrant. Numerator is not off by 1. It's off by more than 1, fourth quadrant. So, with all those pieces together, let's finish our problem. I need the secant of 7 pi over 6. Pi over 6, that's a 30-degree angle. 7 over 6, that's numerator is 1 higher, that's third quadrant. Here's my triangle. Secant is the reciprocal of cosine. The secant, 7 pi over 6, is 1 over the cosine, 7 pi over 6. So I need the cosine of 7 pi over 6. I know it's negative, third quadrant. Cosine is adjacent over hypotenuse. And I want the reciprocal, 2 over negative square root of 3. And here's the best part about calculus. We're done rationalizing radicals. We can leave it just like that. Now, yes, we have to square that because this is secant squared. There we go. We don't have to rationalize it. We are now allowed to have square roots in the denominator, and that's going to be more convenient for certain kinds of problems. Trust me, it gets a lot. Having to rationalize things in calculus makes problems bad. Worse than they really are. Sine 7 pi over 6, or my triangle. Sine 7 pi over 6 is the sine of 30, negative 1/2. Come back here. That's negative 1/2. This is 4/3. Negative 9 times negative 1/2 is positive 9/2. And finishing this off, looks like our common denominator is 6. 8 over 6. 27 over 6. Times 3 times 3. Yep. And that's 35 over 6. And again, in the greater context of the problem, this will make more sense. What we just found is the slope of our line that we need. So now we have the slope. We can continue on later in the fall to find the full equation. This is how you find trig values. Let me do another one, just to pick one. Say I want the tangent. Oh, I don't know. I'll just make up one here. 11 pi over 6. Okay. I look at my fraction. Numerator, denominator are off by more than 1. That tells me fourth quadrant. Over 6. That means I have my origin. Means I have a 30-degree angle. So origin down to the fourth quadrant, x-axis back to the origin. There's my 30, which corresponds to this, positive, negative. Make my short leg my 1, and again it's negative because we had to go down to the fourth quadrant. Hypotenuse is double. Hypotenuse is always positive. And then there's my other side. Tangent, well, opposite over adjacent. Done. Negative 1 over square root of 3. And just because we can, one more. Let's say, let's do a cosecant of, I don't know, 5 pi over 4. No. 5 pi over 3. Let's go make it over 3. Over 3. Now I have a 60-degree angle. Numerator, denominator are off by more than 1. Fourth quadrant. Fourth quadrant. Now this is 60. That means my 30 is right here. 1, hypotenuse, negative square root of 3. This is the x-axis. This is the origin. We went right from the origin. And notice the difference that now our angles are flipped. Instead of 30 being here, 30 is here. Now, if you don't like that, you can draw your triangle this way. You can still do this. Here's your 30. Here's your -1, your 2, and your square root of 3. And I claim you'll get the same answer. So let me go back to my first triangle, the one in black. I want the cosecant. That's 1 over the sine, 5 pi over 3. 1 over the sine of 5 pi over 3 corresponds to 60 degrees below the x-axis. So if we come all the way back around, this is 300. 5 pi over 3 is 300. Sine is opposite over hypotenuse. Negative square root of 3 over 2. Now if I come to the blue triangle, if this is 30, this is 60. This is 30, then this is the 60. Oh, look what's happening here. Because my angles are flipped around, this is going to be a bit of a problem. If I do opposite over adjacent, I'm going to get a positive value. So what happened? What happened? Well, when we draw our triangle this way, when we use the opposite, so this was 60, this is a 60-degree triangle or 60-degree angle, but I drew a 30-degree angle in my triangle. What's happening is I have to do this. I have to invert those two symbols because we're sort of taking our triangle and we're rotating it in a weird way. So if all you want to do is focus on the 30, that's fine, but you have to be careful when you have this different denominator. This denominator corresponds to a pi over 3, which corresponds to 60 degrees. In order to make our angles work out, we've got to flip these two symbols. So we get a weird situation. It's really weird. In order for this triangle to work, we have to flip those symbols. That's really confusing. So, best advice, if that's the 60-degree angle, then use the 60-degree triangle at the origin. And then our opposite and our adjacent sides will flip from the 30 degree. Here, my short leg was opposite. Now my short leg is adjacent because I'm using the 60. The short leg has to be opposite the 30. It just has to be. So you can still use this interpretation, but it's really, really weird. And you're probably going to mess up once or twice before you get the hang of it. My advice, stick with this one. Let me do one with a 45. Let's say cotangent of 5 pi over 4. Numerator is 1 higher than the denominator. Puts us in the third quadrant. because this is a 45, 45, 90. And we're in the third quadrant. They're both negative, and they're both the same value. Here's the hypotenuse, square root of 2. Cotangent is the reciprocal of tangent. Tangent of 5 pi over 4 is opposite over adjacent. Reciprocal, it's 1. That is really bad. That's better. And if we do another one, let's say the secant. 5 pi over 4. That's the reciprocal of cosine. Cosine is adjacent over hypotenuse. We flip it, and it's negative square root of 2. And there you go. Finding trig values without a unit circle. Any questions? Shoot me an email.